Section 1.5, graphs. So in our journey as we kind of explore the basics, some of the underpinnings of statistics, we have kind of started with the population and sample. And at the heart of any study is a population of interest that you're trying to answer a question about. And you take a sample to help answer that question. And we looked at some things about samples. We looked at some different techniques of doing studies. And then we looked at bias, which you really want to avoid so that you hopefully can answer the question in a way that is credible and believable by people. And now what we're going to start moving into, it's like once you've gone out there and looked at all the different ways of doing a sample and you've collected data from your samples, hopefully you've eliminated bias, you've done things randomly so everyone has an equal chance of being chosen, and all that, and you've got a good sample, you've got some data. And once you get all that data, it can be a little overwhelming. If anybody's ever just looked at raw data from anything, it can be really overwhelming. So the next step in trying to answer this question that you maybe started with is to organize the data. And in this chapter, at the end of this chapter that we're looking at here now, we're going to organize the data using graphs and look at some things that go along with that. And then when we get into chapter 2, we're going to start looking at how to organize data using numbers. So we'll see a lot of that starting in chapter 2. But for these section 1.5 graphs, we're going to look at creating a frequency and relative frequency distribution. That's a big part of really forming any graph. You can start out with the frequency and relative frequency distribution to basically organize the data, and then you take that information and put it into a picture to make it stand out a little more. We're going to construct a bar graph. Probably seen these before. You're going to see them here. We're going to look at histograms and be able to identify its shape using special terms. There's some statistical terminology that is used to describe the shape of a histogram. We're going to look at that here. And then we're going to interpret a pie chart. Just looking at a pie chart. We're not going to create the pie chart. You can do this on technology if you want to, but we are going to interpret it and make some sense out of it. And some of this you may have already seen, but it's kind of the nature of the course where not everything is going to be new. So frequency and relative frequency. As I said, organizing the data once you've collected it is important. And the first step is to create a frequency and or relative frequency distribution in most cases, in many of the cases. So frequency, if you're thinking like frequency, like radio frequency, which it's another meaning of it, has not a whole lot to do with statistic frequency. What you want to think of with the word frequency in this class, it's like if you frequent a place, that means that you go there often. So you frequent a certain restaurant. And it's like, oh, well, I go there frequently. So it's related to the number of times that maybe you go there. So in this class, the frequency is going to be the number of times a data value occurs in a data set. That's the meaning of frequency in statistics. And that just means like, if you're doing something with a study and you happen to see that there's 20 people that are 6'4", then the frequency of people that are 6'4" in your study and your sample is 20. Frequency distribution is just a listing of each data value or grouping of data values called classes with their frequencies. And we'll see more with the classes when we get into the histogram side. So you're just kind of, basically making a table that organizes all the different data values that you have showing up in your sample and the frequency of each one of those. Relative frequency, when you talk about relative, you're really relating it to the whole. And why would you want to do this instead of just having frequency? Well, if I told you that 100 people felt very strongly about something, you might be like, oh, that's a lot. Yeah, 100 people. That's quite a bit of people. That means something. But then if I told you the relative frequency was just 100 out of 1,000 that were sampled felt a certain way about something, felt strongly about something, you'd be like, oh, only 100 out of 1,000? Wow, well, that's not a lot. So just that nature of relating a number, the frequency, to the total, it can help put a perspective and give you more of like a fraction or a percentage, a proportion of your sample that is feeling that way. And if you're doing your study correctly, then the proportion of your sample should be close to the proportion of the population. So you can get a better sense of the total number of people in the population that might feel that way. For example, if your population is 10 million and you see in your sample that half of the people feel a certain way, then you'd be able to say that, oh, well, probably 5 million people in the population feel this way. You know, as long as your sample's representative, of course, and everything's done good. But that's kind of the power of relative frequency, is it gives you a relationship to the whole to help put these numbers of frequency into a better perspective. Because as I said, 100 sounds like a lot until you start comparing it to 1,000. And then a relative frequency distribution, it's basically the same thing as a frequency distribution. It's just another column in a table that has the fractions there, frequency divided by the total. So let's take a look at a little example here. And we're going to have these colors, red, green. This is going to be a data set. You might be wondering what the heck that symbol is. I was trying to draw a little squiggle bracket, and obviously I can't draw those good. But you always use set notation when you're listing out your data set. So red, green, blue, then we got another green, and then finally a red. And not a lot of data, but that's okay for the purpose of this example. And then you'll have color. That's kind of the data that you've collected. It's different types of colors. So we'll have one part of our table. You just kind of draw a chart with rows and columns. The columns will have color, frequency, and relative frequency. And then the colors, you just kind of list them here. You can put them in alphabetical if you want, or if you got an order you prefer. I'm just going to put them as I see them. So red came first in the set, green, and then blue. And you only need to list each one time, because the frequency is going to take care of telling you how many times each one showed up. And when you look at the reds, and this is a really small set, but I encourage good skills for bigger sets. So when you start counting things off, go ahead and cross through them. Like, okay, there was a red, and there's a second red. And if you do this, you're much less likely to miscount. So we got 2 reds, and then for the green, we got a green here, green here, green here. So you got 3 greens, and then blue. You got 1 blue. And now you look at your data set, it's like, oh, everything's been accounted for. I've got everything in the list, and I haven't missed anything. Because the most common mistake I see with bigger lists is that you miscount, you miss one. And if you just crossed them out as you went, you would probably not miss them. So just a little, pro tip. So the frequency here, 2, 3, 6, or 2 plus 3 plus 1 is 6. And you do want to get the total here, because to make the relative frequency, you just simply take the frequency divided by the total. So 2 over 6, you always want to reduce. You can report it as 1/3 or 0.33. Sometimes they'll even go to a percent, so this would be 33%. Of course I'm rounding here, but there's a lot of different ways to represent these, and either one of the reduced ones is fine. 3 over 6 is 1/2. And then 0.5 or 50%. And then last but not least, you got 1/6, which is 1/6 or 0.17 after you round, and that would be 17%. And what you're hoping, note that the total of your relative frequencies should equal either 100%, 1, either one, depending on if you're working in percents or numbers, the total should be 1 or 100%. And sometimes with rounding, if you're dealing with large, crazy data sets where rounding has happened, you might get like 99.999%, something like that, or 0.9999 instead of 1. But if you're looking at a bunch of fractions and stuff, you're probably pretty safe in assuming that there was just some rounding that caused you not to get exactly 1. Right, so that's a example of a frequency distribution and relative frequency distribution kind of all in one. You just have your colors, your categories in one column. You got your frequency in another, relative frequency in another. So once you've gotten that data organized in a frequency or relative frequency distribution, you can start putting that data into pictures. So we have the bar graphs, and we're not going to go through all the possible chart types in this class. There's a lot of different variations of the bar graph. We're not going to go there, but we will look at a few of the most popular types of graphs overall. And the bar graph is one of them. We're going to just look at the basic bar graph again. And there's a lot of, even just within the bar graph category, there's a ton. So bar graphs, it's just a graph where rectangles represent the frequency of each data value or class of data values. The bars can be drawn vertically or horizontally. As I said, there's a lot of variation here. I'm going to draw them vertically just because that's the way I always do it. And note the bars do not touch. This is a key thing. We're going to see with histograms, you're going to be like, well, isn't that a bar graph? And no, it's not, because with bar graphs, the bars do not touch, and they are the same width. Humans are funny sometimes, because when you look at pictures, if you looked at a picture and saw a bar that was a lot wider than the others, it might make you think that that one has more in it. And technically with bar graphs, the only thing that really matters is the height of the bar when you're drawing them vertically. So making them wider, narrower, it doesn't mean anything. But when people look at it, they're going to be misled into thinking that the different size bars mean something. So that's why they do them all the same width. And let's go ahead here. So a good bar graph has a title. And let's go ahead and let's just do the example here. I'll write this out what we're going to do. So I'm going to do a bar graph for colors on the first page. So sorry about that. I was getting ahead of myself with the title. So the title here is just going to be maybe pen colors. I've seen all those colors in pens. So pen colors would be the title. You always want to have some sort of title, let people know what your bar graph is describing, or what it has in it. And then you're drawing vertical bars. You're going to have a little thing, looks like an XY graph if you've worked with those before, and you only need the first quadrant, as they call it, or where everything would be positive. And this left bar is where you track the frequency, because you're not going to write numbers necessarily on the bars themselves, but you do need to let people know what those bar heights mean in terms of frequency. And you could do this with relative frequency if you wanted as well, but for this one I'm going to do the frequency. So you have an axis for the frequency or relative frequency. And then down below, you're going to have a little label that lets people know what the different bar labels mean. Red, green, blue. Most people will be able to figure out that's colors, but it's not always that easy, depending on your study. So we're going to have red, green, and blue for the different bars, and you kind of give a label for what those mean. And then these are the actual data values. We saw red, green, and blue for our pen color survey. And then we're just going to draw bars here. So the first one is going to go up to 2. I'm running out of time here, and I'm going to pick this up cliffhanger style.